Hey guys, this is Wyatt from Constellation.
Hi, Altif from Constellation, and what are we going to talk about?
Today we're talking about some new developments, specifically our first pass at partitioning.
All right, so then it'd be good to just start. What exactly is partitioning?
So partitioning refers to our approach to concurrency in our protocol. So the number of partitions that we have can be thought of as the number of, or the parallelism factor that our protocol has. So the more partitions, the more data gets processed.
Okay, so then what does that mean for Constellation in particular?
Sure. So one of our key value propositions is our approach to handling scalability using dynamic partitioning, or the ability to increase or decrease the number of partitions in our protocol as nodes join and leave. So naturally, we want to have as many partitions as possible so we can process as much data in parallel as possible. And what we did specifically was find out or run a test and simulate what actually would it look like if we were to have multiple partitions running in our cluster. And that was really just a test of whether or not our data model, our underlying data dependency graph, was horizontally scalable. And we were successful with the outcome.
Nice, nice. So I guess then for some people who may not know about partitioning as it relates to distributed systems or in blockchain, how is that recent achievement, how does that compare to other things? Like let's maybe say like Ethereum that people know about, or Bitcoin.
So Ethereum or Bitcoin can be thought of as like singly partitioned. So their underlying data dependency structure or their data model can be thought of more so as like a linked list. So every single node in the network works to formulate the next element in that linked list, and essentially blocks the creation of data as that next element is created. So you really have a distributed system that is operating in serial. There are some other approaches. I believe the most canonical or the oldest one would be Zilliqa's, in how they are providing some notion of sharding, where essentially different nodes can federate tasks out to subnodes. And that is, is equivalent or similar to how one would shard a database. What Constellation does is a little bit more akin to how someone would write a large-scale data processing application, something using like Hadoop or Spark, specifically Spark in the sense that the partitioning happens dynamically or according to some type of logic. And what that actually boils down to is a solution to a data locality problem. Who is responsible for what? Validating what accounts or what transactions on the network, and who is hosting what subset of the total state of the network. So one partition can be thought of as like one slice in the total state of the network, like one slice out of a pizza.
So then I did hear you call out dynamic partitioning. And so currently the state of the network is partitioned, but dynamic partitioning, is that where it is now, or is that something that comes in the future?
Yeah, so dynamic partitioning is something that's going to come in the future as we start. That'd probably be the next thing that we want to add after our application support. So we want the ability to increase or decrease the number of partitions as nodes join and leave. Once that's in place, then you can tie that in with a multi-tiered data dependency graph. That means that we will have bundles of greater than one rank in the network, and they will effectively be partitions on partitions on partitions. Your dog, I got a partition.
Partitions. Yeah. So then what's like the next steps from the partitioning announcement up into like dynamic partitioning? Like what comes next, basically, just in general?
So in general, what we're really focusing on is providing an interface for application support. So while we have a lot of work ahead of us in terms of scalability and making sure that our network is truly dynamic, we really want to give people a feel for how they would actually use Constellation to provide some notion of cryptographic security to their existing applications. And that doesn't necessarily require us to have all of the bells and whistles that our final product actually will. So we're really focused on actually providing that interface for application support and focusing on a couple of different types of applications or types of different ways that people can use us in order to improve their existing stuff. So I guess a couple of keywords would, one, be something called mass authenticated messaging, or MAM. This is something that IOTA is doing quite a lot of, which really just is the utilization of our protocol to give a tamper-proof audit trail for the movement of data across the network. And we're also going to be working on something akin to to execution by a protocol. However, that is actually defined in terms of, I guess one could say loosely, like a combinator, or basically how what I had in mind originally when we were describing the actual underlying data dependency model as a high-load chain. So as we span out actual commands, an application can almost be described algebraically. Then we have like a co-algebra that takes back all the information from the original command, the original application's algebra, and then wraps them all together into the final result. So those could sort of be thought of as like two ways in which we are tackling application support currently, and that's what we're going to provide for some of our partners in the coming months.
There's a couple of like quick things. One, node operators, they are, looks like they're up and running.
They're operating.
Yeah, open your ports, people.
Yeah, there's some stuff, but we're out there, we're in the weeds with you guys. So give a shout out to the team for Morale and Tyler for really being out there helping out. And yeah, beta's public, so get in there.
Awesome. And then wherever this video ends up, we'll have a link there. And then just sign up to be a node operator. And then as well as, are you hiring Wyatt?
Big time. So please just shoot me an email on Wyatt and constellationlabs.io. And if you have any distributed systems chops, or honestly, we have job descriptions all over the internet. So please send me your resume and welcome. Come join the team.
All right, cool. Well, that's it.
Yeah, that's it. Thanks, guys.
Bye.